So today's lesson is going to be factoring by GCF. The do now just kind of picks up with stuff from yesterday. Can you combine like terms? And if you take a look at the first two right now and look for some matches in here, if I'm looking at the xy squared term, I don't have any others. What's highlighted, so I keep it as xy squared. For the two xy's, I do have another xy here, which means I've got 3 of the xy's. And then the x squareds are here. I've got 3x squareds plus 1 more x squareds for 4x squareds. Now if I want to combine that with this other polynomial, and the fact that I'm doing subtraction, subtraction is keep, change all. So I'm going to keep this first polynomial as is. I'm going to change subtraction to addition, and I'm going to change all the signs of the second polynomial, which means this becomes a negative, this becomes a positive. Go back to combine like terms, and xy squareds, I've got 1 of them here, but 2 more of them here. So I've got 3 xy squareds. xy's, there's 3 xy's and negative 2 xy's, so that's 1 of the xy's. And then the 4x squared does not have a like term, and there it is. So there's your do now, just kind of a review of yesterday. When we start talking about GCFs, in terms of numbers or coefficients, if you're looking for a GCF, what you're really looking for is the largest number that divides evenly into all of the numbers. Okay? In terms of variables, when you're being asked for a GCF, what you want there is the smallest power. Remember, that's just an exponent of all common variables. So that's going to be your GCF in terms of variables. So what's going to happen is when we start factoring and we do factoring by GCF, it's really like reverse distribution. You're trying to find out what term can be divided evenly by all the terms, and then when you pull that out, that's your GCF. What's left over belongs in parentheses, such that when you check it by distributive property, and you should get the answer that you started off with. So for this first problem, in terms of the numbers, 3, 12, and 15, the number that divides into both of them, or excuse me, all 3 of them is a 3. In terms of the variables, x cubed, x squared, and x, they all share an x, but the smallest power of x is just x to the first. So your GCF is a 3x, and you open up a parenthesis. What you're now doing is taking the original problem and dividing everything by that 3x. So if you want to do it separately, you can say, all right, well, what's 3x cubed divided by 3x? And the answer becomes x squared. What's negative 12x squared divided by 3x? And that answer becomes negative 4x. And what's 15x divided by 3x? And that answer becomes 5. So this is the factored form of this. How do you know? Because if I wanted to check my answer, I would check by distribution, and by distributing I would get 3x cubed minus 12x squared plus 15x, and that was in fact the original problem. So the answer is the GCF outside of parenthesis. You can check if you want. You should go right back to the original. On the second one, when I'm looking for my GCF, what's the largest number that divides in both 8 and 12? And that should be a 4. They both share an x, but the smallest power of x is the x to the first. That's going to go outside of parenthesis. So this time I'm going to talk about reverse distribution to get the answer. I'm basically saying, well, 4x times what gets me back to 8x squared? And I know that's going to be 2x. And then I'm going to say, well, 4x times what gets me back to negative 12x? And that's going to be negative 3. This right here is my answer, because I used reverse distribution, which is just like doing dividing. So it's 4x outside the parentheses of 2x minus 3. Let's take a look at the next one. We've got 21a, negative 3b, and negative 24c. Two ways to do this. Because the leading coefficient is negative, I tend to pull out a negative GCF. You could pull out a positive GCF. Your answer will look different, but there are two correct answers. So I'm going to do it the way that I start out, and I'm going to say, well, what's the largest number that divides into all three of them? And that would be a 3, but because 21 is negative, my lead coefficient's negative, I'm going to pull out a negative 3. There is no common variable, so there's no variable as a GCF. So essentially what you're doing is you're dividing everything by negative 3. So what's left over in the parentheses is a positive 7a, a negative 1b, and a positive 8c. This is your final answer. Now again, I did say that there's no reason why you couldn't pull out a positive GCF. So let's say you wanted 3 to be your GCF. Then your parenthesis would just change its signs. Inside would be negative 7a, positive b, and then negative 8c. Either answer is acceptable. I don't care which one you use. For the next problem, I've got 9x squared plus 36x. My number GCF is a 9. My variable is an x. And then I'm going to do reverse distribution or division in my head, whatever you want. But I know that when I pull out 9x, what's left over is 1x plus 4. Because if I were to multiply back, I'd get 9x squared plus 36x. Next one. So on this last one, in terms of GCF, there's no number GCF, but with the variables, it's going to be y cubed. And then what's left over is 15x plus y. And then that's the end of it. So there is all your practice. Feel free to practice on this page. This is not the homework. This is just some extra practice here. You know what, I will do a couple more. Let me just jump down to like 9 and 10. These look a little bit longer. Your homeworks may or may not be that long. But on 9, 28, 21, and 14, the largest number that divides evenly into all of them would be 7. A squareds, A cubed. My smallest power of A is the squareds. B cubed, B, and B squared. My smallest power of B's are just 1B. And then again, you're dividing or reverse distribution. To get back to the original, I need to have 4 and B squared plus 3 and nothing minus 2 AB. This would be the answer for number 9. If I look at number 10, 12, 20, and 32, I think everything is going to be divisible by a 4. So that's going to be part of my GCF. There's not A's everywhere. There's X's everywhere. So the X's is going to be X to the second. And there's not B's or C's everywhere. So the only GCF here is going to be 4x squared. What's left over? I need a 3a squared to get me the first term. I need a 5b squared to get me the second term, and then I need an 8c squared to get me the last term. And there's your answer for 10. So feel free to do some of the extra practice on this sheet, or you can go right to your homework. That's it.